Hello everyone, welcome back to the channel. Let's continue the model question paper, question number 4. And for question number 3, just refer previous video that I already uploaded in the channel. Let's go to the model A2, question number 4 of model question paper for introduction to electrical engineering. So you can see question number 3 and 4. Question number 3 already solved and uploaded in my channel. Just go through the video and analyze and understand what you have to write exactly for the particular question that they asked in a question paper. Just for your reference, I solved model question paper. So without wasting time, now we'll go to the question number 4. So it is having 3 questions. In that you will be having 2 problems. In that one problem they asked to draw the vector diagram. So it's a kind of complicated problem. Okay. So now see, with the help of circuit diagram and phasor diagram, find the phase angle, impedance and power in case of RL series circuit. We just see with the help of phasor diagram. So with the help of phasor diagram means they only mentioned with the help of circuit and phasor diagram, RL series circuit and phasor diagram. So now RL, a circuit which consists of resistor and inductance in series across voltage source with a frequency of 50 hertz. Okay, so let's draw the circuit diagram. A circuit which consists of R and L across voltage source, that is AC voltage source V. R, L, V, and whenever the supply which is given to the RL series circuit, current starts to flow, so that I'm mentioning that I is flowing, whereas V is nothing but instantaneous value of voltage which is given by Vm, small letter V, Vm sine omega t with reference to frequency f hertz. Okay, so now the total voltage, whenever the supply current that flows through the resistor and inductance, there will be a drop across resistor and drop across inductor. So that a drop across resistor is nothing but VR and drop across inductor is nothing but VL. Okay, so now before drawing the phasor diagram, just have to know here the reference is current. You are taking current as a reference because series circuit current flows to the R is also I and current flows to the L is also I. Okay, so let me draw once again a circuit which consists of resistor R, inductor L across voltage source V, total voltage. That's nothing but instantaneous value of voltage V is given by Vm sine omega t. Whenever supply which is given to this combination, current starts to flow and which divides drop across R, that is VR, and drop across L, that is VL. And here the reference is current because of series circuit. Because of series circuit, the reference will be current. Because current flows to the R is also I and current flows to the L is also I. So how can you draw the phasor diagram in case of resistor? By taking current as a reference now, VR is in phase with current. Similarly at L, by taking current as a reference, VL leads current at an angle of 90 degree. If we club these two phasor diagram, we'll get a resultant phasor diagram of RL series circuit. Okay. So now a circuit which consists of R and L, these all you have to write in examination, and you are applying the voltage V equals to Vm sin omega t, and current starts to flow, and which produces or else which produces two voltages across R1 and across L1. That is, there will be a voltage drop across resistor R and voltage drop across inductor L. So that total, voltage across R, we can write it as VR equals to I into R. This is 1. Similarly, voltage drop across L, you can write as VL equals to I into XL. This is 2. So that total voltage is given by vector sum of VR and VL, the total voltage across the circuit. This is equation number A for your reference. So now draw the phasor diagram. To draw phasor diagram, first you should know which is a reference quantity. So that by taking current as a reference, as I told, why you are taking current as a reference? Because it is a series circuit. In case of series, current flows through the R, that is same as current flows through the L, so that I am taking current as a reference. And second condition for, see now I am taking current I as a reference, current I. So now I is a reference. By taking current as a reference, in case of resistor, VR is in phase with I. So that second point, VR is in phase with I. And the next, for L, that is VL. Again, by taking current as a reference, VL that leads VR at an angle of 90 degree. VL that leads VR at an angle of 90 degree, or else pi by 2. So that vector sum of VR and VL, you can get total voltage V. So that by adding these two vector sum, we can get a resultant voltage V here. V at an angle of phi. So this is the phasor diagram. First, current is a reference, VR is in phase with I, then VL leads I by 90 degree, then by adding VR and VL, that is vector sum of VR and VL, you can get total voltage V. This is a phasor diagram. So they ask you to get impedance. To get impedance, you should draw the voltage triangle. To get impedance Z, draw voltage triangle. Draw voltage triangle, V triangle. Voltage triangle is nothing but I am mentioning here with a reference of this phasor diagram. So you can draw the voltage triangle, that is, I'm just giving you a naming O, A, B. This is your voltage triangle. So O to A represents VR, and this VL, that these two sides are same and these two sides are same. Horizontal lines that will be same and vertical lines also same, equivalent. So that by OA is nothing but VR, and A to B represents VL, and by adding these two, you'll get total voltage V. That is, OB is nothing but V at an angle of phi. So with the help of this voltage triangle, you are getting impedance. So now it is a right angle triangle. So you are applying Pythagoras theorem. By applying Pythagoras theorem, we can write OB square equals to OA square plus AB square. So what is OB represents? V square. So that V square equals to OA is nothing but VR square plus VL square. Okay. So now how will write V? So V can read it as square root of VR square plus VL square. So whereas VR is nothing but I into R, so I can write IR whole square plus I into XL whole square. By taking current as a common, so I square you are taking common. So it comes, if it comes from square root, it becomes I. So that you can rewrite here. I will write it here. So that V equals to square root of IR whole square plus I into XL whole square. So by taking I as a common, you can get I into square root of R square plus XL square. So this square root of R square plus XL square is nothing but impedance. So that you can get V equals to I into Z. So that Z you can get it as V divided by I ohms. Whereas Z is nothing but square root of R square plus XL square. So with the reference of this, again they asked you to write phase angle. So impedance you are getting now. So impedance is nothing but Z. Z you are getting. Z is the square root of R square plus XL square. So if you wanted to get phase difference, you just have to draw the impedance triangle. Whereas this O to A represents R, A to B represents XL, and this O to B represents impedance now with respect to phi. Okay. So now this, if you want to get a phase angle phi, you have to define tan. You know that tan phi is given by opposite side divided by adjacent side. That is nothing but XL divided by R. So that phase difference phi, you can write it as tan inverse of, tan inverse of XL divided by R. That's it. This is the phase difference. Okay. So steps you remember. First you have to write circuit diagram. So once after writing the circuit diagram, explain the circuit diagram. It has two drop. One is VR, that is nothing but I into R. Another one is VL, that is nothing but I into XL. Then you're writing total voltage is given by VR plus VL. So once after this, you are drawing the phasor diagram by taking current as a reference. VR is in phase with I and VL leads I at an angle of 90 degree. By adding these two, you can get resultant voltage V at an angle of phi. After that, voltage triangle. After that, voltage triangle. Then applying Pythagoras theorem. Then you can get V equals to I into Z, whereas Z equals to square root of R square plus XL square. So to get the phase angle, you are defining you are writing the impedance triangle. With the help of that, you are defining tan phi. You can get phi. That is nothing but phase difference is nothing but tan inverse of XL divided by R. So these steps. First to get the phasor, to get the phase angle, and also this one impedance. Then what they asked? They asked you to write power consumed in RL series circuit. So to write the power consumed in RL series circuit, first to define in instantaneous value of power. Whereas the instantaneous value of power, which is given by small letter p, that is given by V into I, instantaneous value of. So to get power, first we define instantaneous value of power. P is given by V into I, whereas V equals to Vm sine omega t and I equals to Im sine omega t minus pi, not pi by 2, because the angle is pi, lagging angle. Okay, so leading angle. Minus pi is nothing but leading angle will be having. So now you have to substitute this value in this power, so that P is given by P equals to Vm Im sine omega t into sine omega t minus pi. So these two, sine A into sine B, a trigonometry formulae. So that is given by 1 by 2 into cos A minus B minus cos A plus B. So that I can rewrite as Vm Im divided by 2, 1 by 2 into cos A minus B, whereas A is nothing but omega t, B is nothing but phi. So you can get cos A minus B, omega t, minus into minus plus phi, minus cos A plus B, omega t minus phi. So you can get now. So now we can write here this P is given by Vm Im divided by 2. So this omega t and omega t will get cancelled. So you can get into cos omega t, sorry, cos phi, not omega t, cos, you can get cos phi minus omega t plus omega t is nothing but 2 omega t cos 2 omega t minus phi. Just open the bracket, you can get P equals to Vm Im divided by 2 cos phi minus Vm Im divided by 2 cos 2 omega t minus phi. So this power is having two component. So the first component, that is Vm Im by 2 cos phi, is nothing but active power component, and one more, that is fluctuating power component, fluctuating power component. So where now we can observe this fluctuating power component is having 2 omega t. That is nothing but frequency of fluctuating power component, that will be a double the frequency of applied voltage, so that this term becomes 0. This becomes 0. So that average power P is given by Vm Im divided by 2 cos phi. So you can rewrite 2 as root 2 into root 2. So you can write Vm divided by root 2 into Im divided by root 2, because root 2 into root 2 is nothing but 2 itself, cos phi. So Vm by root 2 is nothing but RMS value of voltage. It is represented by capital letter V. So that Vm by root 2, RMS value of voltage into RMS value of current into power factor, cos phi in terms of watt. So this is the power consumed in a RL series circuit. So these all they asked to write in a question. Anyhow, they are not mentioned any waveform, so that no need to write the waveform. If they mentioned waveform, you have to draw the waveform. So these all, so the anyhow waveform that will be they are given in a formula handbook itself, so that you can refer a formula handbook for the waveform in examination as well. So this much you have to write. First circuit diagram, then you need to write V equals to VR plus VL. Before that, you have to define VR equals to I into R, VL equals to I into XL, then total voltage equals to VR plus VL. Then you draw the phasor diagram, then you draw the voltage triangle, then you apply Pythagoras theorem, then you can get V equals to I into square root of R square plus XL square, whereas square root of R square plus XL square is nothing but impedance Z. Similarly, to get the phase difference, you draw the impedance triangle, then you define tan phi, that is XL by R. You can get phi equals to tan inverse of XL by R. To get the power, define instantaneous value of power, that is V into I. Then you substitute the value of V and I and simplify that by applying trigonometry rule. You can get two component. One is active power component, other one is fluctuating power component. In that fluctuating power component, the frequency we double the rated frequency or double the frequency of rated voltage or applied voltage. So that becomes 0. So you'll be considering only active power component to get average power. So that Vm Im divided by 2 cos phi. Whereas you're rewriting 2 as root 2 into root 2, so that Vm by root 2, Im by root 2 cos phi. Vm by root 2 is nothing but RMS value of voltage. Im by root 2 is nothing but RMS value of current, so that you're getting P equals to VI cos phi in terms of watt. This is more than sufficient to write in examination. I hope you're understanding. If you are having any doubts, feel free to write in a comment box. So next, we can see next question. A circuit which consists of this resistance of 20 ohm and inductance of 0.05 Henry connected in series, and there is a single phase supply of 230 volts 50 hertz, and they asked you to find the impedance, current, power factor, power consumed by the circuit, drop across R and L, draw the phasor diagram. So till fifth point everybody will do, but many of you are having confusion to draw the vector diagram, so that nothing to worry. I'll just tell you how can able to draw the vector diagram. So circuit consists of R and L, RL series circuit. Now you draw RL series circuit. There is a resistor R and inductance L across voltage source V, RL. So what is the value of R? They are given 20 ohm, and L they are given 0.05 Henry, and the voltage V they are given, that is 230 volts. Frequency they are given 50 hertz supply. Okay, 50 hertz supply they are given. What they asked you to find? They asked you to find the impedance, then the rest of the parameters. Okay, so that you need to find. So to find impedance, Z, you know the formula for this RL series circuit. Z is given by square root of magnitude of Z is given by square root of R square plus XL square. R they are given, L they are given, but they are not given the value of XL. So that first you find the value of XL. You need to find the value of XL. So find the value of XL. XL is given by 2 pi f into L. You know all the values. 2 pi frequency they are given 50 hertz. L is 0.05 Henry. You can get the value of XL. So the value of XL is 2 pi 50 into 0.05. So 15.707. You can get 15.707 ohms. XL you are calculated. So now we can get the value of impedance Z. So Z is given by square root of R square plus XL square. R is 20. So that 20 square plus 15.707 square plus square root of answer. You get 25.43 ohm. 25.43 ohms. So impedance, you calculated the impedance. For the safer side, you calculate phase difference also. Phase difference pi is going to be just now explained, tan inverse of XL divided by R. That is nothing but tan inverse of XL is 15.707 divided by 20. So you can get phi. So phi equals tan inverse of 15.707 divided by 20. You get 38.14 degree. 38.14 degree. This is angle between voltage and current. Because voltage angle is 0, they are given 230 at an angle of 0 degree. Angle between voltage and current is 38.14 degree. So similarly, next what they ask you to find? Current. Second point. First point over. Impedance 25.43. Second point. What they asked the second point? Second point is power factor. So phi you are calculated now. Power factor is nothing but cos of 38.14 degree. That is nothing but cos of 38.14 degree, 0.7864. 0.7864 lagging power factor because inductance is present. There is no capacitance. Second point is finished. Next, what they asked in third point. So third point, they asked you to get the value of power consumed by the circuit. Power consumed by the circuit is nothing but P equals to VI cos phi. You know the value of V, 230 volts, they are only given. 230 into I, you don't know. You need to calculate the value of current, right? So this I is given by V divided by magnitude of Z. 230 divided by 25.43. So you can get the value of I. Second point, sorry, this is the second point. Third point is power factor, and fourth point is power. So I can get 230 divided by, sorry, 230 divided by 25.43, 9.044. You can get 9.044 amperes. We substitute this value 9.044 into power factor. You already calculated 0.7864 lagging. So you can get power P equals to, give me a second, 230 into 0.7864. You get 1635.88. You just verify the answers. Okay. If there is a wrong answer, please write in a comment box. 1635.88 watt power. Next, fourth point finished. Next, what is the fifth point they asked? They asked you to find the values of voltage drop across R and L, that is VR and VL. So fifth point, VR is given by I into R. You know the value of I, you know the value of R. 9.044 into R is 20. Give me a second. 9.044 into 20, you can get 180.88. 180.88. VR is 180.88 volts. Similarly, VL is I into XL, that is 9.044 into XL is 15.707. You can get VL equals 9.044 into 15.707. 142.05 can get 142.05 volts. So now we know the value of VL, VR, and they're given the value of V. They asked you to draw the phasor diagram. You should know the value of current and angle between voltage and current, that is 38.14 degree. So now to draw the phasor diagram, remember the theory first. So what theory says, you are taking current as a reference. So that by taking current as a reference, VR is in phase with I and VL leads I at an angle of 90 degree, and by adding these two you can get the value of V. That's it. First you draw like this. I, you know what is the value of I? 9.044 amperes. And VR calculated, that is 180.88 volts. And VL calculated, that is 142.05 volts. And you know the value of voltage, that is 230 volts. And what is the angle between current and voltage? That is nothing but phi 38 point. You should mention this all 14 degree. And this angle. So if you want to get this angle, 90 minus 38 point That is 90 minus 30 points or 38.14. You can get 51.86, and this is 51.86 degree. So like that, you have to draw the waveform. So very simple. First draw as it is the theory by taking current as a reference. VR is in phase. VL leads I at an angle of 90. Then you add this, you can get the voltage V. Now we substitute the values. That is 9.044, 180.88, and it is 142.05. And the angle between voltage V is 230 volts, and angle is 38.14, and this angle, right, that is 51.86. Okay, very easy. If you're having any doubts, feel free to write in a comment box. First, you find impedance, phi, current, power factor, power, VR, VL, then you draw the phasor diagram. 8 marks they asked. So to find all the 6 values, you will be having 1 marks. For the phasor diagram, we will be having 2 marks. Next, 3 coils having the resistances of 10 ohm. 3 coils having a resistances of 10 ohm. You just see the problem what they asked here. And inductance of 0.02 Henry, which are connected in star. Across 440 volts. It is nothing but star connection. So what is the condition for star connection, or the condition for, or else a relationship between line voltage and phase voltage? In case of star connection, VL equals to root 3 times of VPH, and IL equals to IPH. And coils, it is connected in star. The coil which consists of R and L, 3 coils. All the 3 coils are having R and L. Balanced load, all the 3 load which will be having same value, that is R is 10 ohm and L is 0.02 Henry. This is nothing but impedance. Z. So how will write Z now? Z is nothing but R plus JXL in case of RL series circuit. So that you can write Z equals to R value, you know, 10, but they are given the value of L. You need to find the value of XL. So that XL is given by 2 pi F into L. Frequency they are given 50 Hertz. So that 2 pi 50 into 0.02, you can get the value of XL. Just give me a minute. So 2 pi 50 into 0.02. We can get 6.283. 6.283 ohm. So now we can write impedance Z equals to R plus JXL. That is nothing but 10 plus J 6.283 ohm impedance. Okay. So like this you have to write. So then what they asked you to find? They asked you to find the value of line current. So to find the line current, they are given the value of voltage V. So if they are not mentioned anything, means they always given the value of line voltage. They are given line voltage VL. VL is 440 volts. You need to find the value of VPH. That is VL divided by root 3. 440 divided by root 3. You can get 254.03, I guess. 440 divided by root 3.03. 254.03 volts. So once after getting VPH, next you need to find the value of IPH. IPH is given by VPH divided by modulus of ZPH. Either you can use write this. See here, they are given both magnitude and direction, so that you should write the value of Z. not modulus of Z. Okay, so Z, Z is nothing but 10 plus J 6.283 Z. So you can get the value of IPH, that is nothing but VPH is 254.03 divided by Z is 10 plus J 6.283. Use your calculator in complex mode. If you are having any doubts regarding this, please go through my playlist. I uploaded one video how can solve the problems in complex mode. Keep your calculator in complex mode. Then you write this 254.03 divided by, in a calculator always you should write in the form of A plus IB. That is, in your calculator you have to write uh, in the form of 10 plus 6.283 I. Like this you have to substitute 10 plus 6.283 I. So you write a polar form, convert this complex form into polar. So you can get 21.509 at an angle of minus 32.14 degree amperes. They ask you to find line current. You got the value of phase current. But what is the condition of star connection? IL equals to IPH. So that you can write IL equals to IPH equals to 21.509 at an angle of minus 32.14 degree. Okay, you should write in polar form, remember, because they are given a complex form, so that the current which is having both magnitude and direction, but while solving power and power factor, it is a different case now. So now we can find the value of power factor. So second point, to find power factor, first you find phi. Phi is again tan inverse of XL divided by R. XL is 6.283 divided by R is nothing but 10. So you can get the value of phi. Tan inverse of XL divided by R, that is 6.283 divided by R is nothing but 10. So you can get 32.14 degree. 32.14 degree. Phi is 32.14 degree. So that you can get power factor equals to cos of 32.14 degree, that is nothing but cos of 32, 0.8467, 0.8467 lagging power factor, because it is having inductance. So power factor you calculated, and the last point is to find the value of total power consumed. Remember, power is a scalar. P is given by modulus of V into modulus of I into cos phi. So VL, sorry, it is a three-phase. Sorry, it's a three-phase. So that you should write power is given by root 3 into VL IL cos phi. Root 3 into VL IL cos phi. That is root 3 into modulus of VL, modulus of IL into cos phi. What is the value of, you can write here, root 3 into VL is 440. Remember 440 VL. IL is only modulus is nothing but magnitude 21.509. Cos phi is nothing but 0.8467. So you can get the value of power P to 21.509 into 440 into root 3. So you can get 13.879 kilowatt. 13.879 kilowatt. This is a power, 6 marks. For each parameters, 2 marks. Okay. So this is about the model question paper solution of module 2, that is fourth question. So there is a problem text. So if you are having any doubts regarding this, feel free to write in a comment box. So just observe the problems carefully and take the screenshot wherever it is necessary. So I hope you are understanding. Thank you for watching this video. And last but not least, uh, please do like, share as much as possible, and don't forget to subscribe. Thank you so much for your support. So just wait it for model 3 questions of model question paper. I'll upload it very soon. So thank you.